Let's talk a little bit about gravitational potential energy. Something has gravitational potential energy when it's some height above a lowest point. So maybe this is the floor, and you've got some mass here that's some height above that. Okay. Now, remember that work, which is force times distance, that's a transfer of energy. So to derive all these formulas, I'm going to use something called the work energy theorem. And the work energy theorem says that if you do work on some object, it can gain an energy equal to the amount of work that you do. So that's true in this case, right? So all I have to do here, this is actually the simplest one, right? The work I do is equal to the force times the distance. The force is equal, since I'm lifting, is mg, right? And the distance I'm lifting it is h. And so this just becomes mgh. Okay? So that's our formula here. And that is our potential energy. Right, so here's the formula. You might want to pause and write that down. Okay, but this is our formula, right? So h is the change in height, and m is the mass, 9.8 newtons per kilogram. That's our g, right? Okay, so if we have 5 kilogram mass, that's 2.1 meters above, right? That's 2.1 meters, and that's 5.0 kilograms. Okay, our potential energy is mgh, right? So it's 5 times 9.8 times 2.1, right? And this is kilograms. This is newtons per kilogram. This is meters, right? So the units are going to become Newton meters, right? So 5 times 9.8 times 2.1 is 102, and the units are Newton meters, which is of course 102.9 joules. Yeah?